Okay, now we are going to solve problem 12 from MIT Integration B qualifying, and the problem is integral from 0 to pi over 2 of sine 2x cosine of cosine x dx. And I want to simplify this expression a little bit using trigonometric identities. So here I have sine of 2x, which is equal to 2 sine x cos x. So I can rewrite this as integral from 0 to pi over 2 of 2 sine x cosine x, and we just copy the expression after it, cosine of cosine x dx. And I can take out 2 outside the integral here, and we are going to do U-substitution. So I will let t is equal to cos x, and that will means dt is equal to cosine, not just cosine, minus sine of x dx. And we need to take care of the limits of integration. So when x is equal to 0, cosine 0 is 1, so t is equal to 1. And when x is pi over 2, we get t is equal to cosine pi over 2, which is 0. So let's put this into this integral, and we have 2 integral from 1 to 0, and sine x dx is minus dt, because this can be written here, and cosine x is t, and cosine of cosine x is cosine t, and yeah, sine x dx is minus dt, and we want to get rid of this minus sign by flipping the integration limits. So this is from 0 to 1, and the negative sign is gone. Okay, now we have this simple integral to integrate, and we will using integration by parts. So this will be our u, and this will be our dv, and because u is t, so du will be equal to dt, and dv is cosine of t dt, so we will get v is equal to sine t. And we need to plug all of this into the formula of integral u dv is equal to uv minus integral v du. Okay, now let's plug all the parts into the integral. So we'll have 2 multiplied by the quantity of, okay, uv is t multiplied by sine t, so I will have t sine t minus integral of v sine t du is dt, so it's become a nice integral. And don't forget the limit of integration. We integrate from 0 to 1, and here also 0 to 1. Okay, now let me evaluate this. So for 0, sine 0 will be 0, so we only need to take care of this 1. So we will have 2 multiplied by the quantity of, this is 1 times sine 1, so we will have sine of 1 in radian, and integral of sine t dt will be minus cosine of t, yeah, and that will make our sign of integration become plus, and we'll have cosine of t from 0 to 1, and let's plug this in. So I will have 2 sine 1 plus cosine of 1 minus cosine of 0 is 1, and basically we are done. But I want to multiply these two, so 2 sine 1 plus 2 cos 1 minus 2, and here is our final answer. Hopefully I did not make any mistakes in the calculation, and thank you for watching.